Okay, good morning, ladies and gentlemen. Thank you to be here this morning for the executive session on sharing knowledge in exploration. It's my pleasure to chair the session with Christine. Very early in the discussion during the local advisory committee, you know that we have to discuss the theme of the conference and the topic of the executive session. And during the discussion, the first session was really dedicated to the need to have a session relative to the knowledge in exploration. And really, it was a joint discussion and key priorities for all the participants of the LAC to be sure that this topic will be captured during the EEG 2017 in Paris. So what is the topic? It's really to have an open discussion, and it will be guided by subtopics that will be discussed with key participants. And you see the various topics that will be covered. And we are very glad to have Dirk Smith from Shell, who will start to introduce the first subtopic. Dirk is Vice President, Exploration Technology and Chief Scientist Geophysicist in Shell. He will cover a topic to show what other industries are doing in terms of sharing knowledge. And with a key example, a project that has been done in Shell. The second subtopic will be introduced by Rémi Echard. Rémi Echard is head of the Department of Petroleum Basin Evaluation in Total. And he will show what we are doing in terms of basin mastering and technical knowledge in Total with a global perspective and ongoing project. The third subtopic will be discussed introduced by Tim Dodson. He's Executive Vice President Exploration with Statoil. And he will focus on knowledge transfer across the great shift change and new competencies and the requirement of this and the impact of this great shift change, and he will explain what are his main message. The last part will be a discussion introduced by Gary Ingram. He's Vice President Exploration and Appraisal with OMV. And he will focus on knowledge sharing and management, strategic performance indicators. You notice that we have to, unfortunately, have the cancellation of Joseba Murillo from Resol. Unfortunately, last Sunday, he had a bike injury and he cannot travel. He broke a rib. I will share the session with Christine Wood. So thank you, Christine, to share the session. Christine is VP Exploration Excellence and Chief Exploration in Shell. We also are welcoming the international connection. You know that all the executive forum yesterday, executive session are online on Facebook. And the way that we'll organize the session, we'll have, so for each subtopic, a presentation from the speaker I introduced to you. And at the end of the presentation, we'll take your questions. So you may use the application, the app application from AEG website, very easy connection, and we have a direct link to our system like that. After, we'll animate the debates and the questions. So you go to program executive session on knowledge management, and you will have an icon where you can interact, and you will ask your question. You can put your name on or anonymously as you want, and we'll make sure that your questions are asked for the debate. So with this introduction, thank you for your participation, and I let Christine introduce the first subtopic.
Good morning, everybody, and thank you for coming. It's my pleasure to introduce Dirk Smith from Shell. As mentioned, he's the VP for R&D Exploration Technology at Shell, and he is also the chairman of the Shell Science Council. And he's going to start by bringing an external perspective to us and talk to us a little bit about what we can learn and how we can share knowledge across industries, not just within the industry. So with that, I'll hand it over to Dirk.
Oh, thank you. Let me see whether I can get hold of this. You can see my slides, I cannot, but that's... So I'm going to show you a few, I would say, teasers, because of the time, that I think look very promising coming out of the medical imaging industry. This work would not have been possible without a key researcher from Siemens, who is also here, Kevin Xu, who will field all the difficult questions related to medical imaging. If I try to... This happens when lawyers take over the company. Sorry? That is my presentation, yeah, that is correct. All what I say shouldn't be used to buy any shares or sell any shares in Shell as a result of my remarks. Then on to the more exciting bits in my view. We have partnered with Siemens over a few years now to learn what topics in medical imaging in particular could be of use in geophysics. And as you could see from the title, in particular for quantitative interpretation or QI. And Siemens has had a long history and legacy, in fact, in medical imaging. It is active in all aspects of medical imaging, from inpatient treatment to remote sensing. And here you see a sample of what they are, in fact, developing. They're mainly active in producing technologies that are then used in the medical system by medical doctors or specialists, as well as perhaps by patients themselves. It's a rich field full of technologies that are similar to what we try to implement in our industry. It's also a field that, probably because of the volume of the subject, it's only a body that you're scanning, is a little easier to implement than perhaps large-scale, rich data problems. There's a lot of machine learning and data analytics that is deeply integrated in the imaging and interpretation process itself. Something that I think we as a geophysical industry, no matter how far you are, is probably a little behind of what is happening in the medical industry. And I will show you a few examples to show you, first of all, how fast this field has been moving. This is an MRI scan of a head, and you see here the brain. You see on the left, perhaps only because of the location you can identify it as a brain. On the right, you see the first images of what a brain actually looks like. But modern technology actually shows you here what actually the neurons or the interconnects in that brain that you just saw can be revealed by high-resolution MRI scans. I think we can use that later on as I show you. But before I do that, another example of a CT scan in modern medical imaging that actually on the right shows almost as if it is a real picture of actually something inside your body. You wouldn't recognize this as an image per se, more like a real 3D object that you could look like, say, as an experiment. So high-resolution imaging certainly has taken a significant step forward. In fact, if you look at what the resolution is compared, say, to the wavelengths that they can scan, then we have something to learn in geophysics from that as well. Now, what is interesting is that Siemens has developed as well techniques to make 3D interpretations of complex bodies a lot easier. The brain actually cannot do right away 3D imaging or 3D interpretation. It always uses 2D slices, as people have found out, many of them along many slices and many directions, and then it combines in your brain into a 3D image. That makes it difficult, fundamentally, to really navigate accurately in a complex 3D body. And to show you the techniques that Siemens have developed, that I think we will be using also in, for example, interpretation of subsurface data, is to essentially use, say, by machine learning techniques, a method that actually unfolds and I hope I could play that. Let's see, that movie. I don't think the movie plays. That's unfortunate. It is playing. And now I need to go back because that's the other. Okay. Tell me if it plays because I cannot see that. In any case, you see here a rib, and that's of course a 3D body. By actually looking precisely by a machine learning technique that on a real patient actually figures out what exactly the central line is of your rib, you can fold open this rib and actually navigate precisely within those ribs, which is done using the controls that you see here on the right-hand side. That is a technique that we're using now as well in Shell, actually to unfold some of your seismic. We do this by reconstructing the seismic. But this has taken it a step much further and makes it much easier to identify anomalies, say, or at least areas where you would like to have more analysis. I think what is also very important is that you can augment the reality by techniques to superimpose on an actual real image of, in this case, a beating heart, where a valve has been replaced by a surgeon. These valves have been modeled ad infinitum, say, by the industry, and hence the specs have been modeled precisely. You can actually make flow models of how such valves would use, and by a data adaptation driven by machine learning, you can superimpose that model of a valve into a beating heart in real time, and so as to see whether indeed the valve is positioned rightly to indeed do its work. Or if it isn't, then indeed some minute changes could be made right during the operation. So you're essentially using this model to forecast the performance of this valve while implementing it in a real situation, not in a model, by using the models of the valve integrated into this beating heart. Something that we perhaps would like to see take advantage of in predicting how equipment, say, downhole could work, where we could actually have similar real-time observations coupled with models. This is an art, in my view, or a science that is deeply ingrained now in medical imaging, used on a day-to-day basis. It's not that we don't know about those medical images in our field. I mean, the CT scans for small rock samples or core samples in core labs is well known and leads to fairly high resolution images of core material studying, say, pore geometries and perhaps even permeability aspects. We need to go a step further, though. We really need to understand as well, certainly when you're dealing with carbonates, what are the chemical surface reactions when rock starts to interact with fluids, or fluids starting to interact, in particular multiphase fluids, with the rock material or the pore material. We all know that from studies that a lot of the chemical reactions and the rate of which these reactions are actually determine in small pores what the permeability conditions are. And hence for flooding, either in core floods in the lab as well as later on upscaled in the field, it's an important question to be asked how effective those models could be. And hence, as a result, we need very high resolution imaging, I claim higher than we can do today. And in particular, we would like to know how we can capture and model the chemistry of rock fluid interactions. I think that field is still emerging. We're using synchrotron beam lines coming out of synchrotrons these days. Shell does this in nearby Geneva in CERN to study some of these advances. But in fact, there's many more aspects. What you could do if you have these models live is in fact a model where you could actually show the fluid modeling. So this is in fact a reservoir simulator, if you wish, in a heart, in a beating heart. Again, the heart is actually real, and the flow in that model is completely determined by a model that actually describes aspects of 3D flow models in such complicated 3D structures. I think that we can learn something of that to understand the dynamics of our reservoir. And inching towards that, I would argue that we can actually start to see the movement or the wettability of rocks studied in the lab by indeed CT scans, but I would argue that there is a lot to be learned from how to do this interactively and on time scales that actually matter, i.e. where the chemistry is actually driving to displace these fluids. Now, I'd like to take you back to something that is far more mundane. Those examples that I showed you are examples in a lab. We actually worked with Siemens to build something on how to automate and interpret with much more accuracy seeps, naturally occurring seeps in the deep sea. And the aim is to actually have a method available at 2,500 meters of water depth or even deeper. We do this by side scan sonar. This is a very old technique and recipe to seek working petroleum systems, of course, in frontier basins. But of course, not every seep is what it is you think, is what you think it is. It could be of biogenic gas or biogenic origin, and hence maybe not so useful for exploration for live hydrocarbons. In other words, you need to first of all understand where are those seeps, and secondly, you need to be able to analyze them in a way that actually could point towards the possibility that these are of thermogenetic origin. It's a technique, as I said, that is even older than seismic, but the way we analyze this is pretty arcane still. I mean, that is also because the water depth and the techniques that we have to deploy are not easy to deploy, but in actual fact, it's a purely manual process. So there's a high chance that you miss a seep, and there's a high chance that even if you see a seep in real time on a side sonar data, that you essentially miss this. So what we've done is we actually used some of the imaging technologies that we just saw and actually created a fully automated system that actually detects out of sideband sonar exactly where those seeps are. And from the mechanics already, not from the chemical analysis, but from the mechanics of how these bubbles rise or how they actually, what their behavior is, their mechanical behavior, dynamic behavior, we can actually infer already quite a great deal. It turns out, the elastic properties, for example, that allows us to conclude with a probability associated to that, of course, whether these seeps are indeed of thermogenic origin or biogenic origin. And to show you some of that, I actually have a movie. And again, you can see that here. What you see on the right is the side scan sonar as passing over a piece of seafloor. And what you see in the left is actually the camera that actually detects those seeps in an automated sense. Now you may wonder, well, what's the new here? Well, what is new here is what you see there upright. That is in real time, how these seeps are picked up. Each time you see in the upper triangle a bleep, that is actually confirmed a seep that actually is arising. This is a fully automated process. It's no longer too sensitive, say, on a manual or person interpretation. And as a result, you actually get a seafloor picture of all these pinnacles standing up, which is on the lower left here, a picture of what those seeps are. What I cannot show you here is, in fact, the attribute that actually will allow you to detect whether this is indeed of thermogenic origin or biogenic origin. And this is still in the absence of a chemical analysis. I think what I would like to stress is that this is a field that is open for us to explore with much more vigor, in my view. These are just a few teasers, if you wish. I think you can actually make significant advances in subsurface data interpretation thanks to the availability of large-scale computing as well as the accuracy of the data that really now comes of age and allows for far more, in my view, sophisticated 3D interpretation, both interactively as well as using supervised automated learning. I think we can also actually expect that workflows of how to actually shorten the decision-making process from acquisition to a decision process based on data a lot shorter by following techniques and practices as in the medical imaging. The number of CT scans in the world made per year is about 100 million. If they would interpret that in the same way as we would interpret seismic data, a lot more people, in fact I claim a substantial portion of the world population, will be needed to actually interpret all those things and bringing them to a decision. So there's a significant efficiency gain implemented in the medical imaging industry that we could probably learn from. And as I said as well, we can really make advances into perhaps initially under lab conditions to augment reality and superimpose complex 3D modeling on top of real data in time-lapse mode if you wish, to understand more precisely what the interactions are that we do with the subsurface could mean for future production. I think those are 3 reasons that in my view are just the tip of an iceberg where I would, at least I'm very excited, or we are very excited here in the QI group and with Siemens, and I think there's more to come. So thank you very much for your attention.
So please feel free to type your questions into the phone. As you're doing that, I'm going to ask a question to the panel here. Obviously, there's clear value in collaboration with industries other than the oil and gas industry. What do you see as the biggest challenges to those types of collaborations, and how do we overcome it and become more externally focused in this space?
Is that a question to me or to my...
Go ahead, you can start.
Yes, I can start. Well, I think there are 2 big challenges. I mean, first of all, from a distance, it looks like, well, you can just copy and paste what people do in another industry and hope to do that as well as in our subsurface characterization efforts. It actually takes a real detailed discussion to see what you can apply and where things are really different. For example, in the medical imaging industry, people don't have to worry about, for example, the velocities or at least the elastic properties of the medium that they're scanning. It's either water or bone, and the velocities and the parameters to govern, say, the elastic constants there is well known. That is one of the big unknowns, in fact the unknown in subsurface, and in fact part of the whole reason to do seismic imaging, for example, or other characterization techniques. So it's not immediately clear upon second look what in fact you could use. I do think though, so it requires a good understanding of what it is that you really would like to resolve and where in fact the questions that the medical imagers have asked themselves and advanced their techniques and to what extent those questions are similar or perhaps even identical to in the subsurface. But notwithstanding that, I also think that we have come from a past where we were pretty insular and pretty inward looking. If I don't want to claim that that holds for other companies, but certainly in Shell, there were times that we, Shell, were actually asked to sit only in the back of a conference taking notes and not interact with any of the papers, only not to reveal what we were working on. I don't think that that is a very healthy way of actually advancing a field. Nowadays there are many, many more people who actually contribute to our field. And in order to advance, you will not be able to do it alone, and hence we need to come up with a completely different culture that is far more driven by curiosity of what others are doing in the hope that we can learn from that and advance our own fields rather than by the competitiveness that we perhaps would like to retain with that IP. And I think you can see how the companies, at least Shell, is struggling with how to actually create and implement deeply that culture. So there is a bit of an inhibition there too. But we'll get there, I'm pretty sure.
Looks like Tim wants to chime in.
Yeah, maybe I could just build a little bit on what Dirk says there. And I regularly ask the question myself is, why do we appear to be so slow to adapt, if you like? And I had the pleasure of being at the Formula One race on at the weekend in Montreal. And really struck by their ability, sort of on the fly, to make use of absolutely all data available to make super fine adjustments. Sort of. And then I asked myself the question: so why are they doing that, and we apparently are not doing this? Yeah, big industry if you like, sort of, but we're a big industry, we're a much bigger industry than this. There's more at stake really than winning a Formula One race. And I think couple of things from my point, and I'm not going to get too technical about this, but I think I think sometimes we struggle with our legacy. Sort of we kind of, as you say, Dirk, sort of a little bit inward thinking. We're basically using the same techniques as we were using. So back in the 50s, you talked about seep hunting and side scans, sonars, and the way we've done this. And I mean, it's an old technique, and only now maybe we're applying these sort of super modern sort of techniques to and automating that kind of process. Drilling techniques, so the seismic techniques. Of course, we've made the advantage, but basically, it's the same basic technology, sort of at this. And I think there is much more to be had in terms of sort of applying these sort of new methodologies which have been exploited to a much greater degree, for example, by the medical industry or even the car racing industry, if you like, to do this. We are slow to adapt and change. So I think it's something about our mindset. I think our legacy, which I believe gets in the way. I don't pretend to have the solution. I'll come back to it a little bit later in the session here, but I think it's a question that's worth asking ourselves. My speculation is that for some reason or other, even though it is a competitive industry, maybe it's not competitive enough. If you're customer facing, or you're trying to win a Formula One race, you don't have a choice. You don't have a choice. And I sometimes wonder whether that's a little bit of the issue for us as an oil and gas industry. Are we really competitive enough? Because I think if we'd had to be sort of even more competitive, then I think we would be pushing these boundaries much quicker than we are.
Okay, thank you. We have various questions on use of technology which are evolving quite rapidly around how can machine learning be used for access exploration. A medical example is perhaps more relevant with a production geoscience setting. So I don't know if you have experience in or ongoing project in your activities with the use of artificial intelligence and machine learning.
Perhaps if I just make a comment.
No.
Is it working? Yeah.
Now it is.
If I just make a comment on this, the machine learning, it's not something that I have experience with, but it's something that I've realized recently is highly significant. If you take, for example, a typical 3D data set, maybe it's 4,000 square kilometers of offshore seismic, and you imagine the number of shot points, every so many meters and so many depth points, you could have billions of data points. And I mean, we have to admit that the human interpreter cannot possibly, in a period of months, go through all those billions of data points. So I think clearly there is room for help in our industry to reach out to this technology. So really my observation is that it's something that really has to be investigated and moved further, because if you look at our success rate in the industry, of maybe 1 in 5 projects is commercial, then clearly we would like to have some help. And I think by looking and investigating as much as possible all the data points that we acquire at vast expense will help us.
Can I
Go ahead, Dirk.
comment on your question? It's a very good question, because most exploration, certainly frontier exploration, is in data poor areas compared, say, to areas where you produce, where you probably will have a lot more data. You certainly have production data. So it is a good question to say, well, look, what do you then understand by machine learning? Well, I think if I limit that, say, to a company the size of Shell, there is a lot of knowledge in the company, locked in human beings, where a lot of interpretation experience of how to recognize subtle aspects in perhaps indeed poor data areas, to actually assign uncertainties much better than when done by someone who doesn't have all that experience. So one of the challenges we face, and I think that's a doable or solvable problem, is to quantify more smartly what that knowledge actually is that is locked in the staff of these of our explorers. And one of the things you could probably think of is that core databases. We have thousands of kilometers of cores. We have lots of fluid samples, about 7 or 8 million samples across the globe over a long period of time. If you would have that completely digital and the ability to make metadata structures out of that, that will be all relevant at your fingertips when starting to interpret, say, aspects in how to interpret subtle geology, even on seismic. And that's even apart from the fact that Google was able to actually make face recognitions possible by looking at billions of faces. I wonder what we could do with images of pre-stack data, of which we also have lots and lots of, and see whether we can actually learn a few rules that are hidden in the data that somehow are probably difficult to extract only by very experienced interpreters. I think there's an area, therefore, to uncover, and I would indeed hope that in a year or so or two, I will be able to, or some of my colleagues will be able to explain some of the advances we're making in that space at conferences like this.
Remy?
Yeah, I think there is no doubt with the amount of data that we have to manage, that artificial intelligence can help us to classify, compare, rank, I would say, and provide guidelines to guide the interpretation. There is no doubt about that, because of the huge amount of data that every day we have to treat. But take care at the end, the experience and the brain of the geologist will be the final decision maker. So it's a dream for the management to have a machine which provides you the prospect, the best prospect, and can arrange really and reduce the uncertainty. But it's only a guide. It's only a guide. And at the end, the experience of the teams and will be the last decision maker, really.
Yeah, Tim? Yeah.
Could I? Is this on? Okay. When it comes to machine learning and that, I think it's something about taking the right first steps, if you like. I think one of the shortcomings which I experience and have done sort of throughout my career and continue to do that is that the simple but laborious tasks which involve sort of collating large amounts of data, be it analog or digital data, they tend never to get completed because we as human beings we get worn out after a while, so we do it for days, we do it for weeks, we do it months. Just take the well, all the wells in the North Sea, a couple of thousand wells. How many people, or how many persons, how many human beings are actually interested in 2017 in working through, first finding the data, and then working through and trying to sort of make sense of a certain element of those data, well logs or something like this? We know what the answer is. It doesn't happen. It doesn't get done. You never complete the task. But machine learning, I think, lends itself particularly to these kind of simple but laborious tasks. And I think this is where the low-hanging fruit is, the quick wins, if you like, that you can get in there, you can analyze. It doesn't have to be millions of data points or billions of data points. It can be thousands, because thousands is more than enough of a kind of a threshold for human beings not really to want to work with this manually. So I think it's we have all these sort of fantastic techniques, but it's maybe some of the simple fundamentals, the basics, where machine learning can really help us and give us a significant lift, if you like.
I couldn't agree more. And I would argue machines will never replace a geologist. Don't get me wrong. I don't think, in fact, it would probably strengthen the role of a geologist, because there's so much more in your hands as a geologist when interpreting that.
So maybe I can add one more point. I'm Kevin from Siemens, and first of all, Dirk, thank you for present the wonderful topics, and we'd be happy to be part of your working with your team on some of your projects. So as Dirk just showed some of examples, so we are actually being very heavily using machine learning and nowadays artificial intelligence technologies to help us parsing, analyzing, and interpret the medical data. And I do share with your opinion that I think we're not going to replace radiologists in our world, like just you say, right? But still, I think the power of artificial intelligence technology nowadays is really superb. So you heard, like you mentioned example, like machine can recognize human face, and machine can be the world champion of Go, which is known to be very challenging, complicated. So the sophisticated computation, the modern artificial intelligence technologies, basically is enabling us to do all these nowadays. So I think we should not, in a way, like we should try to embrace this new AI technologies and harness this and make good use of it. And actually we are doing aggressively within Siemens, try to push that boundary in the medical imaging field. And I hope like in the same thing could happen in geoscience as well.
Thanks.
Okay, thank you. Okay, this part will be finished. We'll move to the second subtopic. And so Rémi Echard, so from Total, who is head of the team in charge of evaluating the petroleum basin, will show what we are ongoing, a project ongoing in Total in terms of basin mastering and knowledge retention.
Good morning. Is it working? Yeah. Yeah, I just put together 3-4 slides just to share with you some very basic ideas about the way to improve really the knowledge sharing within a company and retaining. I would like, and I would be really happy to get your feedback about the initiative you took in your own organization. So Total is a big company, as many companies in this room. We are almost 700 geoscientists working in exploration. So the sharing of knowledge is really a critical issue, a critical challenge. And also we are in a peculiar period where we have a massive retirement of geoscientists. They live with their experience, they live with their background. And on the other side, we still recruit a small amount of people because of the economic restriction. So I mean, it's also a critical period for the knowledge retaining within the companies. 2 years ago, almost 2 years ago, we had a restructuration within Total on the exploration structures. We created 5 hubs in Total. One in Houston, who makes the exploration for the whole America. One in Singapore for Asia and Pacific exploration. One in Pau, in southwest of France, where we have a technical center, and now there is also the hub who is managing exploration for Africa. And in Paris, where we have the headquarters, we have also 2 hubs for the Middle East and the other one for Europe. So it's a big reorganization in the company, and this new structure, I mean, emphasizes really the region accountability, both on a financial point of view and also on a technical point of view. The region must be accountable for the technical studies that they deliver within the hubs. So it's the creation of these hubs. We after 1 year and a half feedback, we realize that really it promotes the initiative of local regional teams, new ideas, new ways of handling data. And also, the reason to create these hubs was to strengthen really the regional knowledge. So the team does really the work, the regional work, and they are not asking for other structure within the company to do, for example, the regional synthesis, etc. And also the creation in the hub, especially in Houston and Singapore, we hired local people, and we realized that also it's an enrichment in terms of culture of the enterprise to have these people coming from the outside with different geo-culture and also different background in terms of professional experience. So now in the headquarters, there is no more regional synthesis group making the synthesis for the others. But the role of the Explo in the headquarters, especially of the exploration excellence, is to revise the processes at the corporate scale, to give some kind of standard workflow and standard criteria to evaluate the assets and to evaluate the prospects, so that the Explo management can really rank the prospect with the same criteria. So we define the workflows, we define also the data of the format of the data, sorry. Also the technical center in Po provides some expertise and technical support on specific skills. And at the headquarters, we also capitalize the data itself and the knowledge at the corporate scale. And to capitalize this knowledge, is that working? Yeah. So almost 1 year ago, we started a big initiative on what we call basin mastering. Yeah? It's really going back to basic geology. But we realized that the Explo team were often in a rush, often describing really the prospect at the local scale, forgetting a regional context, forgetting a global vision of their basin. And so we wanted to put back an effort on this basin mastering. Again, the regional team being accountable for this work. So it is an effort because first we define some criteria to make this kind of play maps with standard graphics and also with the same approach, so that we can share easily our knowledge at a local scale. And also it's a way to fight against the team turnover. Every year we have to, of course, to renew the teams. And with this play map approach, with this basin mastering approach, we really capitalize the knowledge at a corporate scale with the same standard. So it's also these play maps, or I mean the workflow that we propose at a corporate scale is a way also to continuously update our knowledge in the basin with new data, with new ideas, with new concepts. And so it's really a capitalization tool for the company. Of course, it requires some specific effort within the assets and within the region, because there is a massive effort of digitalization of the data, and also a massive effort of reformatting the data to agree with the corporate standards that we are now imposing. But we think that it is a tool for knowledge capitalization and data sharing. And of course, this basin mastering approach is a decision tool to select the best approach in a new venture approach, and also to reduce the risk and uncertainty when you are working at a prospect scale. We have also some initiative to improve cross-fertilization between Explo teams. it's difficult, I mean, to make communication between Singapore and Houston just because of the time. And so we encourage some initiative in the Explo team to share good practice and knowledge with return of experience, with well post-mortems that we share quite quickly with the Explo team so that they can enrich also their knowledge from the experience from the others. To find also relevant analog is still a challenge. I mean, to find the relevant one, not to find an analog. And of course, this cross-fertilization between the team can really help to find the right one, and so to de-risk frontier and emerging play thematics. The conjugate margin vision is, of course, critical when you are working in Brazil or in Angola. Of course, the sharing of knowledge is absolutely critical, but of course, you must also understand the specific context of your margin, and the transcription of a play in a margin is not direct on the other side of the ocean, and so there is all this understanding of the margin evolution, which is also critical. So to share information in real time, of course, we have to rely on web initiative, on web tools. And so, as I guess in every company, we are developing these specific web communities where the people can share in real time their experience and make a return of experience on the plays that we are working on. And also, we put together some kind of webinar session, almost one every week, very successful, where people really are present during 30 minutes, a thematic. I mean, it can be a methodological issue, it can be a presentation of a prospect, so that everybody around the world, around the total world anyway, can have access to this information in a short time period. And also, we, of course, to improve also the experience sharing, it is for sure that the team turnover facilitates the sharing of experience within the team with sharing of, for example, the experience between different regions, turning the team between the different regions. And just to conclude, also must keep in mind that the input of the outside is critical. We have seen that really this morning. Input of other technologies. We have really to encourage also the initiative taken by the academics and the service company, despite of the harsh economic conditions that we have to face. But anyway, it's crucial to have an input from the outside. We have to challenge our concept. We have to challenge our paradigm. So the breakthrough generally comes from that, the crossing of culture, having new ideas coming into the company from the outside. This academic initiative or service company initiative also provides some complementary data sets that we do not have time to collect, outcrop data, etc. We are also looking to weak signals. On this slide, you have a SIPS. It's really critical to identify the SIPS. It's a weak signal that we are chasing all over the world. And this local expertise of people is critical to add some new information in your knowledge. And of course, this academic initiative and service company is also a way to train the new talents and of course to hire at the end the best in our teams. So I will be really happy to share this vision with what you do in your company, and your feedback is really welcome. Thank you.
Okay, thank you, Rémi. So we still capture the question, and thank you for your feedback. There is a first question on standardization. It's true that in our studies, we integrate various data, which are a huge variety of format. And part of the work team is to put all together to the same format to standardize. So one of the questions is, do we should we make more effort to have a joint approach with other company and contractor to have a standardization of the data and the information? So I don't know if you have an experience around these topics.
Well, it's a good question. It's already difficult to make a standardization within the company. To be clear, the process that we are on, which is ongoing in Total, shows that we have to keep the right balance between standardization and flexibility in the teams. So it's not easy, not so easy to impose a standard within the company, so to get the same way of presenting the data, let's say. And also we have to keep the flexibility. We have to hear also the experience from the other, and we have to update our standards, capitalizing also on others' experience. So I mean, it's already a challenge within a company. In the past, there was some initiative also coming from, especially from a service company, to standardize the, IT data, let's say. I don't know really what is the feedback after 10 years. The POSC approach, which some companies tried to impose, or I mean to propose to other companies. Was it really a success after 10 years? I don't know. Do you have an experience on this?
I can say something on standardization. I think we've achieved quite a lot to standardize subsurface data, but I wonder if I see at what cost that comes. It takes out a lot of flexibility in the teams, and even if it doesn't do that in actual reality, it certainly comes across as taking out flexibility in the team, so people feel boxed in. And in my own view, in a world where we essentially are lacking imagination of what to do with the data, I wouldn't be necessarily pushing for a lot more standardization, and essentially ask data analytical tools or modern IT to take care of standardization or exchanges of data between platforms, etc., under the hood without any bothering by people explicitly to be focused by that. It's more like how I work with my iMac that doesn't come with a manual and still knows how to copy and paste things from one platform into another. And essentially free up people and give them the impression and also the space to really open up and do things that are really out of the box.
I agree that too much standardization can really kill initiative and can kill creativity in a way. So we have really to find the right balance, and that's really an issue. In terms of costs, that's clear that any standardization means cost, means effort to digitize, etc. On the other side, redoing 3 times the same study has also a cost for the company. And so with the team turnover, it's really an issue. And if we do not have any way to standardize the data and the knowledge, We redo every time the same work. And so we cannot also find new ideas because we have to come back to the hard data and start again the interpretation of the basic data. So really the challenge is to find the right balance between a standard at a corporate scale and let the initiative and let the creativity to the local scale to also challenge the standard.
So we have another question from the audience here. This is a question that I actually hear a lot in my day-to-day work, so it'll be interesting to hear the perspectives from the different companies. The question is the preparation to present and share data with other teams delaying doing the real work and mandatory tasks? I think another way to ask that question is if you're spending a lot of time sharing information and data, is that keeping you from doing core work?
Yeah, so that's a big debate that we have with the assets, of course, in the region, which are always rushing. I did this job before. I know what I'm talking about. Always rushing with time, always rushing with constraint, budget constraint, and also time constraint. So we are of course fully aware of that, and we don't want to, of course, stop the work of the team, because of course this is the core business of the company. So the exploration management designs some basin mastering team within the region who are really in charge of the basin mastering. So they help really the assets and they capitalize the knowledge of the assets. It's a small team, huh? But anyway, they are really they have a dialogue with our assets, and their job is really to capitalize the knowledge and the data. So it's on the side of our exploration business, and of course, it seems to work after 1 year.
It looks like there's a lot of energy around this one. I think Mark and then Tim and then probably Dirk, they all have something to say on this. So Mark, please go ahead.
Oh, Gary, sorry. Okay. I mean, the question is, does the act of sharing within teams, create some inertia or delay? But I would rather say that, we have quite a lot of diversity of thinking within our companies, and I think it's our duty, it's a discipline that we need to get to make sure that we get the inputs from the different ways people are observing or thinking about a problem. But of course, the discipline is to close that discussion effectively and have a conclusion and then move on. Because often you may see that there are very clever people who are discussing all these different views, and then it continues and it's rather open-ended. So I think you need to have the discipline to have these sharing sessions, because everybody thinks in a different way. And it's healthy to have that debate and get that feedback and challenge. But you have to have the real discipline as a geoscientist to say, yes, as a group, here's the conclusion from that discussion, and move on from that. So it's healthy to have it. I don't see it as a blocker. It should be a way of giving some creative space to people to have their input. It's a discipline,
Tim?
I'm smiling at this question because I hear it. I hear it pretty often as well. I think there's horses for courses, and I think we can link this up to this standardization kind of thing. Sort of, if we sit here as management, decision makers, and we box people in too much in terms of demanding certain kinds of presentations for ourselves, which again detract from doing the core work. Sort of, well, maybe we need to bridge that gap in a different way, and we can sort of work smarter, more intelligently, by actually sharing the same tools, for the same purposes. Visualization rooms, whatever it might be. We actually just instigate a working environment pilot to test out a lot of these different technologies, with the aim really to try to sort of bridge the gap between the teams, the projects, working with the subsurface and management, so that we kind of have an interactive environment, which serves multi-purposes. And I think this is the way to go. we've standardized in one area in particular, and I think it's one of the ones you were pointing to in terms of the quality control of the work we do, sort of not just the process, but in the way that the results of our work are presented to that group. So that is one area where we've chosen to standardize, where I think is particularly important so that we can get calibrated globally. But otherwise, I think we're seeing that we're actually going this way rather than standardize. I think we'd rather open up and, as you say, Dirk, sort of challenge our IT colleagues and these others to sort of actually handle the different data formats and in the way our human brains can handle those different ones, rather than this endless, sort of strive to get everything into the same format, because you get there and then suddenly it just goes like this again. You get there again, and it just takes off again. So I don't think we're in control of that process.
Okay. Dirk, did you want to comment on that?
Yeah, I thought that the answer to that question was very short. In my view, it's yes. I've been there myself for many years. I do think it comes with the fact that there is an enormous hunger for data and certainty at all levels in the company, and there is a natural reaction to always ask for more, as if there were absolute certainty somehow beyond the horizon. I think what I try to do, at least in my own organization, is to build the discipline within the management team. So look, you have one shot and that's it. So make sure you understand what this discussion is about, rather than coming back each time. Because it does take people from work, and the amount of effort and time that goes into preparing slides for board meetings, etc., is absolutely hilarious if it were not that serious. And I try to at least make sure, look, present it in a way that you think about it, and if that doesn't fit a template, then that's fine. Right? And we're actually in the active mode of information sharing, and to think that information sharing is done via a template is really, in my view, wrong. But there is a degree of standardization necessary, and one area where I think you made a strong point is safety. That's the HSNE policies in Shell are characterized by an absolute standardization. And I think that's an area where you really don't want to have too much creativity on figuring out what the procedures or how to apply procedures. But in an area where you really have to rely on what to make of this with a lot more uncertainty, I would almost argue that we've, as an industry, are erring much too more on trying to get to decisions by standardization and templates, and it shows. It stifles. It stifles the time it takes to get to a decision, at least in Shell. And that is something where we really can learn from other industries, where the tech industry, for example, or for that matter, pharmaceutical industries, where that time to take FID is a lot shorter, and inherently because people are more disciplined on at what time what information is important.
Okay. We have a comment which is quite interesting. It's I will read the comment. Whoa. Back to basics versus creativity. There is a conflict there. Back to basics versus creativity, there is a conflict there. I'm not sure, but because we had a lot of debate internally in Total about the need to go back to release the data, the consistency of the interpretation relative to the data. And it helps a lot, in fact, to think new ideas when we have a consistent view of the knowledge. So I don't know if you notice on one of the Rémi slide, each time we have a play map, we have on the corner data. We call that data set adequacy. So we are really careful on the fact that. An interpretation map, a play map, is really compare with the knowledge of the data, the data and the knowledge we have of the area. So, and it helps a lot. It is not because we have a lot of data that, or low data that will not be creative. So maybe I would like to have your feedback on that, the relation between, in fact, the basics and the creativity.
Yeah, I don't see any conflicts here. I mean, you can do a charge play map so a basic charge play map by integrating up-to-date and very new concepts, and which can reduce the uncertainty on your maturity, on your. So I'm not sure I see the point. Really, you can really. I mean, when I said back to basics, okay, it's we have to share. I mean, basic concepts to describe the petroleum system at a rule, but behind, you are free to put what you want in terms of technology, in terms of new insights, in these maps, and you have to do it really. You have to push forward the technology and the new concept. So maybe the term back to basic is not the adequate one, but really I don't see any problem by being technology push, I would say, and anyway present some basic play elements to give you an insight on your petroleum system at all.
Dirk?
Yeah, I must admit, I also don't think there is really a conflict there. I think it can be extremely liberating by focusing on what are really the basic risks. And I think one of the slides you showed actually shows what the basic risks in exploration are, whether you have charge, whether you have a reservoir, whether a seal. And hence, if you're clear about how to actually make sure that you have answers to those questions in any decision of whether it's a farm-in or a well, etc., then the rest of the space is bare open. And in fact, it can be very liberating by making sure that at the end of the day, it's an extremely simple story that has to have a narrative or a storyline around those four risks and how you judge them. And bringing that clarity, some people call it basics, I would say it really shows that you understood what actually the overall integrated uncertainty may be and what it boils down to in an actual project. So I couldn't agree more that basics is presumably a prerequisite to become a lot more creative in a functional way.
Okay. Thank you. One last question on this topic, and then we'll move on. It's a bit of the reverse. We're talking about the importance of knowledge sharing across teams within the organization and the value of that. Are there examples that you're willing to share in your companies where not sharing info across organizational boundaries or across teams has actually destroyed value, or you've lost opportunities because of that?
Who's first? I'm prepared to at least admit in a field that I myself was involved in, and that had to do with indeed the conjugate margin slide that you showed. It's extremely difficult for a company that works, of course, usually in joint ventures, whether it's either operated or non-operated, but usually in a minority shareholder, to make sure that information is shared across, say, conjugate margins. And a very nice example is Brazil versus West Africa, where this is not trivial to actually, because of access of data. I do think that the company that I work for had made mistakes in the past to think that plays in West Africa are very similar to, for example, in the Gulf of Mexico. From a distance, that is definitely true. But in reality, at detail, I think the risks around, say, the four aspects that you mentioned in your talk, it actually is different, and you really need to understand that. And we learned that the hard way. There are other areas where I would argue that perhaps by serendipity, but nevertheless, we benefited hugely from say, the ability to make these cross links across continents sometimes, or at least across countries around a conjugate margin very effectively. So it goes back and forth. But data access and the ability to work with various stakeholders that may have not the same interests in actually capitalizing on the similarities or on the underlying principles that would unite, say, these conjugate margins is a very big challenge, and therefore it can go wrong. Yes.
Tim, I think you had a comment.
Yeah, maybe a couple examples on that. I think it's always different in exploration to sort of know whether you, I guess the easiest way to know whether you missed out is, sort of big discoveries in your backyard or something like this. But a couple of examples, I think, from ourselves where I think where we probably missed out, and not necessarily because we're not sharing, but because we're not doing. And I just want to sort of relate back to the presentation here about the importance of regional work. I'm a really true believer in, where you found and developed and produced a lot of oil, you're probably going to continue to find more. So the prolific basins tend to get more prolific. For us in Statoil, sort of Norway is the backyard, the North Sea, if you like, and it's a highly prolific offshore basin. But for many years, we basically didn't update our regional work for the North Sea. And we were facing a situation where we were struggling to identify new prospects, new drilling candidates. We changed this about 5 years back and really focused our efforts, sort of refocused our efforts onto the regional work in places which we thought we knew well, applied new data, sort of broadband seismic, but then not least all of our knowledge. But actually we did it. We just decided we were going to make a dedicated regional effort. And out of that, we've generated tens of new opportunities, sort of across the border. So in a way, whether we missed out, I don't. Those opportunities have not been drilled. So hopefully some of those will be successes. But I think it's kind of an example of that. The way we work is iterative. We have to come back and we have to work all the time, from the regional to the prospect scale, and then you revisit and you revisit and you acknowledge your data. Then I want to share a second example with you. Last year, early last year, I was pondering over something, and the thing I was wondering about was whether I felt pretty sure that there were more ideas and more to share out in the organization than actually was coming through, at least to me. So we launched a prospect competition with a moderate prize, a geological prize actually for people to try to go on the field course of their choice. It wasn't more than that. We had 134 new ideas coming from the organization, prospects that somehow hadn't sort of filtered through the system before. And of those, I think we've actually made applications in different areas for a couple of tens of those, maybe 20 or something like that. And I think what it's demonstrating is that, I, as is responsible for the exploration business area, probably not facilitating the right kind of sharing process, or somewhere within my organization there are barriers which are not letting these ideas kind of percolate through. So, basic mechanisms again, how do we get this knowledge, these ideas from people to sort of flow, through the organization up to the top, across whatever it might be. So, an example at least, and maybe something to follow for others. I don't know.
Okay.
Very nice.
Mark, we'll let you have the last word on this topic.
Yeah, just a comment here. I mean, in our industry, there's a couple of main ways, I guess, at the front end of the business to bring in, say, potential reserves and resources. One is by exploration, and another way quite often is through corporate M&A, where exploration acreage or even discoveries are acquired. So I just want to highlight that, we got to make sure that when an M&A organization is going out to look at potential assets, that there's not the tendency to ignore, say, the input that can come from exploration to actually give very clear due diligence advice. So there should not be this kind of cut off or prevention of sharing from that part of the corporation. I can't give any specific examples, but I have seen where there have been difficulties in this regard in our company, where M&A is maybe going off and leaving behind actually the corporate knowledge that's sitting in exploration when they're actually looking and even valuing the upside of an opportunity to acquire. So it's really just a warning that we should try not to have that problem where one part of the organization is really, for whatever reason, kind of ignoring another part which could actually help them very much in doing due diligence and actually giving advice on value of an opportunity to be acquired.
Okay. Thank you very much. So now we're going to move on to the next topic, and Tim Dodson, a reminder, EVP for Statoil. He's going to talk to us about another topic that's near and dear to my heart, which is the knowledge transfer across the great shift change, and also what are the new competencies that are going to be required in our industry moving forward. So Tim, over to you.
Thank you, Raj. So I'll try to do this really quick, and I've already shared quite a few of my thoughts in the debate already. But what I wanted to do, as I said, was just to talk about knowledge transfer and the competencies required. And I'm going to keep it at a pretty high level, or actually a very, very high level, if you like. Changing workforce, changing competencies. If you look at this slide, the top part of this slide is basically from Forbes. It's the oil industry's great crew changes called. This was published on the 4th of May 2015. And it's basically saying at the top, and you might be able to read the type, it's small for me, it's probably maybe even small for yourselves, but it's basically saying that 90% of oil and gas executives know talent shortage is an issue. 50% of our workforce, and we're no different in Statoil, and you can see the demographics of my organization on the bottom part of this chart, 50% of that workforce is retiring in the next 5 to 7 years. There's a huge demographic gap. Again, our fault, sort of in the workforce, so you can see, sort of, and big, sort of build up in demographics, between 35 and 55. So we're short on the front end and short at the back end, if you like, just to put it in layman's terms. For every 2 people retiring, we're only recruiting one new employee into this. Maybe that's the way to be. I'm not actually suggesting that might not be the right thing to do, because I think we can work much more efficiently going forward, that we actually need less numbers. And then to the point which I made a little bit earlier, sort of, we're still using the basic techniques, and let me stress the basic techniques, from the 1950s, with almost 1980s technology. At least if you make this a comparison, sort of, I'm really putting out there, I'm provoking in a way, but I'm saying I think so the uptake could be significantly different. Average age in my organization is about 45. The average university graduation was 1997, and just to put that into sort of a more global context, Google was founded in September 1998. So sort of things have moved on since the average employee in my exploration organization graduated and joined the company. So I guess the future workforce in exploration could be characterized by the term fewer and older. The question was asked yesterday, I think, in the executive panel about what skill sets are being lost and what is coming. And I think there is a big question to be asked about how does the industry transfer the knowledge between the groups. I think we all agree that knowledge does need to be transferred. It will be important, maybe even more important in the digital age, to have geologists who can actually sort of, do the core work, if you like. I think we see too many examples of being able to do some very sophisticated process. We asked a question about, so what's the geological concept, so between what you're presenting, come up stumps, so the geological concept has actually not been thought about. then I think we need to ask ourselves the question about what kind of people are we bringing into the industry today? Sort of, what are the graduates? Will they, are they different from 20 years ago, or is it more of the same? Then finally, how can the industry retain the lessons learned from the past and then add the sort of current advancements in efficiency and harness the future power of a digital revolution? So I'm on this digital slide now. And in Statoil, we, and I guess most of the other competitors there, we have a lot of focus on that. It seems to be sort of the fashionable thing to talk about. And we are in the process of developing, like others, a corporate digital center of excellence. We've already touched on this, the impact of machine learning, artificial intelligence, etc., etc. Yesterday, we heard from the executive panel that there's a lot of focus now, but shortening cycle times. At the same time, we sort of see that using the masses of data that we all have to go from from idea generation through maturation is still quite challenging. And we need to be able to sort of test, or to analyze that data and to test it much quicker than we historically have. In terms of competencies, what are we missing? Well, I know what we're missing within Statoil. We're not missing geologists. We're not missing geophysicists. We probably are, though, missing something which you can call data scientists, if you like. Those can build those algorithms, but those that can work together with the geologist and geophysicist. And this is a big problem, big challenge for the industry, because these are probably some of the most popular graduates sort of out there. And just to give you a statistic, what concerns me a little bit, Statoil is pretty big in Norway. We are, without doubt, the biggest listed company. Traditionally, we've been extremely popular amongst engineers, amongst geologists, amongst economists, IT students. Each year, the Norwegian Statistical Bureau, they produce different statistics about the most popular companies within the different disciplines. As I say, Statoil has at one point in time, not in the last 2 to 3 years, been #1 when it comes to IT students. Where do you think we are now? We're number 14. Number 14. Which company do you think has the most data by far? And I'm not saying by far, several orders of magnitude which to apply data science. Us. Of course. So we have an issue. We have an issue. And the issue is really about attracting the right kind of competence, if you like. And we're actually no longer competitive in certain segments, including IT or data science, if you like. So we have to find solutions. We need one to be more attractive, and I think that comes to something to do with branding. But then we probably also need to retrain our geologists and our geoscientists. And I think that's possible to do, because we've always had large volumes of data, and we've always adapted to that. People of my age, we're used to working seismic on paper when we had 2D. We've adapted to 3D, we've adapted to 4D, we've adapted to sort of modified 3D techniques. So I think that the solution actually lies as much within our companies, on adapting the competencies which we have. So I think I'm going to leave it at that. And just some highlights, and then I look forward to the questions and debate afterwards. Here.
Yeah, thank you, Tim, for this message. I think we share part of this concern. We have the same in total, I would say, staffing concern in terms of age, competency. My question, and it's part of also one of the comments here in the system, that is relative to the effort that you are doing to the university, in relation to the university, school, to know if you have changed your message relative to this school to attract new talent.
Okay, maybe I'll comment on this. So far, I would say that we haven't done that. But I think as an industry, we seriously need to consider changing that message. And I think it's really about branding. The oil and gas brand actually doesn't work particularly well anymore. But the data brand could. And I think this is maybe what we need to create sort of greater appeal to what we work with, sort of with industry and across, if you like. You can think about it in a kind of matrix dimension. Oil and gas is kind of the umbrella, if you like. But as I say, the opportunity to work with sort of huge amounts of data and very complex sort of technological challenges, it's always been there and it continues to be there. But that's not really what we are kind of, that's not our top line message, if you like, to the universities, to the employers of the future, if you like. So I don't have all the answers, but I'm convinced that sort of we have to sort of change our brand. We have to sort of sell ourselves in a different way, I think, in order to attract the talent which we need in the future.
Okay, Gary.
Yeah, Tim, you've really kind of provoked my thoughts on this, and you've pointed out something that's very clear. We're in a new world. I have to say that senior management in oil and gas companies generally are what you would call, I say, pretty much old school, and they think about data rather trivially, and don't seem to understand that we're hugely data heavy in our business. Data is our edge. When I think about how people think of data trivially, they say, oh, the guy that does the data loading, the IT guy. They really demean this part of the business, and we all know as explorationists that at the very beginning, dealing with data is our business. It's the majority of the effort that you spend to actually provide that creative space, which is that little bit at the end, which allows you to make options and then make decisions. So you've really highlighted, Tim, that it's not just that we should focus on engineering graduates and geoscience graduates. We should actually be elevating this area which you've called data science. I think it's a very simple and understandable description. We are an industry that has exciting levels of data. I mean, look at those images you see of the seafloor, subsurface. It's fantastic. We have to open the door to these data scientists, as Tim has said. That's the new brains that will come in. And thanks for bringing that up. I mean, it's just really emphasized it here for me. OMV, where we focus on connecting with recruiting very clever and wonderful engineers and very clever geoscientists for exploration and production. But I think we're not giving enough emphasis, and we're rather trivializing this aspect of data. Data is our business, actually. Our data are our business. And I hope members here in the audience will also appreciate that. We're in this new world, and we have to wake up to it.
Yeah, I mean,
Yeah, just a comment about Total. I mean, in Total there is a strategic change. I mean, at a corporate scale, from fossil energy also towards new energy. Clearly, we are investing in solar business. We are also investing in storage, electricity capabilities, etc. So there is this shift, really strategic, at the company scale towards new energy. So it can attract also new talents, and it can also, dépoussiérer, how you can say that, put dust out of our old business point of view. And this is a major change for the company. And the image also of the company is evolving from fossil fuels towards new energy. So it may be a way also to attract new talents and to get the best ones in our business. And afterwards, within the company, of course, we can also make, they can change between the teams and exchange also the experience between the teams. So that's a way also to attract the new talents, changing also the image of the company.
I have I don't know, Dirk, you have a question, or because there is another one that could be also for you.
Okay.
It's relative to the link between academics and the oil industry. We always, all major companies, work closely with academics on R&D, on technological aspect of our business. Do you see still a big attractivity, interest from the academic to work on the oil and gas industry?
Is a question to me?
Yeah.
It depends probably where you are in the world. In my observation, there are differences between, say, schools on the west coast of the US, or for that matter, even in the east coast. But they're not as big as people would think. It's not true that our industry is out of vogue. I think that's a self-inflicted image that we somehow feel that we have. When I talk at MIT, there are lots of people who still come to Shell, in fact more than we had in the past. They're attracted by large-scale engineering challenges, and they're also attracted by, indeed, the data challenge. They're less attracted by the fact that, we believe that oil and gas will be there forever. Some people claim that. Forever, in my view, is, say, the next 5-6 decades or so. Right? That is beyond my life expectancy, so practically that could be forever. I don't believe that myself. Changes are a lot more rapid than many of us in the industry are willing to believe, perhaps. But there are also areas in our company where we embrace that challenge and in fact are stimulating that transition by indeed becoming an energy company. And that energy company is characterized by data. It's characterized less perhaps by hardcore science in the traditional way. It is challenged by hardcore science in a data-rich environment where modeling and thinking that you know all the parameters up front and then try to forecast is changed by how to deal with data and essentially learn from the data directly and make equally important predictions or assessments of risk and come to options. And if you explain how that actually happens in all aspects, whether it has to do with a brownfield that is close to decommissioning towards a wind farm, then a completely different picture arises, and we are then in a fantastic space, I would argue, to attract lots and lots of people, that people who would argue or that we think would be more attracted to the high-tech companies lack. After all, we are indeed providing energy to the world collectively. That is changing the world fundamentally, as it has done over the last century. It is changing in the way it does that. So my storyline is there's no better time than to join, say, an energy industry because there is so much more data. And as you said, the data repository we already have is outpacing lots and lots of other industries. And hence, indeed it comes to rebranding, perhaps more on one hand, engineering capabilities that will continue, as material science opportunities, as well as data and computing. And it is probably our lack of imagination above, with people in management positions, say above 55, like myself, to actually not being able to radiate that. But that's what I think we should be doing far more. This is the industry for the next coming decades.
Okay, thank you. We have maybe a follow-on to that, but first I want to apologize to Gary for repeatedly calling him Mark. I've got Mark on the brain today, so. There's two questions here that I think are related, and it says, the first question, a new professional profile is being designed by the current scenario, and that's a data scientist. So does the panel believe that geologists will become data geoscientists? And then maybe an alternate spin on that is that, oil and gas operators don't seem to be fully comfortable with this specialized space in IT and data science. So is there room for specialized service companies to support geoscience in this space?
Well, if I can maybe respond, I think we do have data geoscientists, and as I said, I think management rather trivializes them, and in fact we don't have enough of them, and we should encourage to build that capacity. I mean, obviously we're functioning as companies because we have such people, and actually they're very rare individuals that you see actually, because they are not their presence is not facilitated in the company. So data science, our data scientists do exist, but not in big enough numbers, I think. And what was the second aspect of the question? Sorry.
Well, I guess the other question was, given that we're not doing very well at that, is there actually room for some specialized service companies to take on that role?
Yes, is the answer, and I believe that there are companies out there who are doing this, and perhaps they're not being listened to enough. But perhaps I'll let Tim. I think Tim was itching to respond as well. But the basic answer is yes, and it's a business opportunity for sure.
Okay, thank you, Tim.
So I think, as I alluded to, I think it is part of the solution. It's probably not the only solution. I think we will need a number of true specialists, especially the guys who can basically have the programming skills, who can build the algorithms. But that's definitely not enough in ourselves. And if you think about our industry, I mean, we've already gone quite a long way to integrating different skills and competencies. And by that I mean that traditional roles, the traditional role of the geologist, whether it's a structural geologist or a sedimentologist, and then the geophysicist or the interpreter. I mean, they've been broken down in most companies, and at least with ourselves, and I understand from sort of a lot of the peer group, we have more sort of integrated geoscientists already. Most geologists are interpreting seismic as well, and vice versa. So this, we've already gone to that stage where you're sort of integrating the geoscientists, and I think the next one is to integrate to a greater degree than we already have. But then I think we need to recognise we've already done a lot of that as well. This data science aspect. I mean, these people are used to working with sort of lots of data in that. But I think some specialisation, but some further integration. I think that's what it's about, and it's. I believe it's fully possible, and I don't want to sort of create any kind of misunderstanding that sort of trying to sort of dramatise, if you like, the picture in terms of sort of the lack of talent and everything else. And I agree with Dirk. It's not. We haven't found it really sort of particularly a problem to recruit new talent, but I think we do need to think about what kind of talent we're recruiting, and not least our own competence development programs within the companies. Further integration, I think, of competence and skill sets. I think that's the way to go.
Okay.
Yeah, we are in the same way of thinking in Total right now. We had for years and years geologists and geophysicists, two separate way of thinking, two separate skills, and now we will regroup that in one, which is geoscientist, with a specific way also of making your career towards what we call prospect generator. So it's really the integration of everything, every data and every competency. And I think also that the evolution of the tools, goes in that direction. Now a geologist is able to make a seismic interpretation on a workstation every day. So the difference between a geologist and geophysicist at the end is what? Time depth conversion, maybe? Not so critical. I mean, critical. I mean, but maybe not so an issue than 15 years before. So I really agree with you. The sharing of competency is now on the way. It's and what we call prospect generator, typically in Total, is the integration of every data and every concept at the end to identify prospect and risk the prospects.
Okay, thank you. So we'll move to the last topics. So Gary Ingram from OMV, you are Vice President Exploration and Appraisal. And you will so introduce the last subtopic with a presentation on knowledge sharing as a critical factor in a critical success factor in exploration.
Okay. Thanks very much for the introduction. So good morning, everybody. Bonjour. I'd like to begin this discussion just by sharing some thoughts and observations from my own experience in my career working in the oil and gas business. I mean, I'm a geologist. I was an explorationist for the majority of my career. What I want to share with you a little bit is knowledge sharing within joint ventures, so where there's different, normally competitors who actually choose to work together in a venture, and how knowledge sharing is a critical success factor within those joint ventures. I'm also going to talk about knowledge sharing actually between competitors, so they're actually in a competitive situation, but they choose to share data for strategic reasons and for practical, and in fact, in many cases for safety reasons. I want to also reach out to governments, government regulators, and also highlight to you, the really key effect that they can have to facilitate the sharing of knowledge. I mean, some countries are shining examples, and other countries are really lagging very far behind, but government regulators can have a big role. Also, I want to highlight, I think we've mentioned it earlier here, the role of research groups, consortia that provide vehicles for comfortable sharing between competitors of critical pieces of knowledge that will help everybody at the same time. Okay. So just a few words at the beginning. Our business, as we've been discussing here, it requires extensive knowledge. And when I say knowledge, that means data. We're very data heavy. We've discussed that quite a lot here. But to make those data create options, we need, of course, to have capability and experience in our groups. So when I talk about knowledge, I talk about those three things together. And then we can make investment decisions from that. It's pretty clear, it's pretty rare to have all the knowledge of a region or basin residing in one company. So it's clear that we're not all on the same level playing field. But what I'm going to say here is that knowledge sharing, can facilitate, on the wider sense, investment in license rounds. So if you're a government regulator, if you're able to facilitate sharing, it's going to attract investment. Yeah. With extensive data, you can make more quality investment decisions. You can ensure safe and efficient operations. All of us as prudent operators want to make sure we do everything that's in a controlled manner. Safety becomes a very, very first factor. Also with sharing of data, you can facilitate higher success rates. You have more information at hand. And also at the end of the day, you can have shorter lead times to monetizing or to a discovery, and also to monetizing the discovery subsequently. Of course, it has to be admitted that knowledge can be seen as a competitive edge for companies, and many companies have very strict policies on data and information disclosure. But I mean, this can be controlled. It doesn't need to be totally compromised, of course. So many governments have, for example, open file data provisions. So after a certain period, the data have to become available, like in the UK or New Zealand, Australia, etc. But you can also decide to make strategic disclosure for mutual benefit, and that can be through research consortia, data trades, or you can even make publications, of course, in international journals. So that's just some statements at the beginning, but I want to give you some clear, concrete examples. One example that I'm really happy to share here is OMV, Petrom, and ExxonMobil have a joint venture in the Black Sea in the Neptune block, and there were a number of really positive things. It was a very positive collaboration in the exploration phase. We're two different companies, ExxonMobil, extremely large company, OMV Petrom, a smaller regional company. But there was a willingness there to understand each other's strengths and come together and get the benefits of what both companies had to offer. OMV Petrom had the regional knowledge, ExxonMobil had the strength of capability and technology. So we had a lot of technical workshops, interactions together, we had regular communication, and at one point ExxonMobil actually executed one of their proprietary technologies, which was their full waveform inversion technique, which was actually something which had a very positive result in visualizing the subsurface. In the end, we drilled the first well in the Western Black Sea in Romanian waters, deep water, and we made a discovery in 2012, which was extremely pleasing. And I'm convinced that was really a critical success factor. There was the fact that the two companies got over that threshold in order to share openly information in that joint venture to help achieve this success. So that's one example of an OMV group company working with another international company. Second one here, talking about sharing between competitors. This is an example here of, in 2015, Shell drilled a very challenging and pioneering well in Turkey. They knew it was probably going to go into overpressures. And, they drilled this well safely, and they had got information from other competitors about what they were likely to encounter. But for this particular well, the venture of Total, Repsol, and OMV, who were in the neighboring Bulgaria license area, they had an agreement to share safety-critical information about the pressures, so that we could ensure that we have a safe result from the well that followed in Bulgaria. So there was a willingness of Shell and TPAO to share those basic safety data with us and our joint venture operated by Total. So this was a critical success factor, again, I believe. So I'll just show you the location of the well Polshkov 1, drilled in 2016. By the way, was a discovery, so that always helps. And this is a schematic of what we drilled through at that point. So again, competitors sharing information, giving a positive result in terms of safe operations. And as a byproduct, we got a discovery. So another aspect I wanted to talk about here was knowledge sharing, facilitation by governments. So I'm just giving a few examples here. NPD in Norway clearly is doing a very efficient and very disciplined job of facilitating sharing in the industry in Norway. New Zealand is an area where OMV is working, and we're very pleased with the way that it's very structured and very much in a facilitating mode for data sharing. Data becomes available after a set period of time. So it's a level playing field where if you're there, data eventually becomes available. And then another interesting one here, when I worked in Indonesia before, there's Patronusa Data is a government controlled body which actually has a very efficient data sharing facility there in Jakarta. Some of you may not know that, but again, it takes some effort to set these things up. But it's facilitating business for Indonesia and is a critical success factor for attracting investment. And then finally, just a couple of things just touching on the research groups and consortia. For example, there's the Seismic Amplitude Analysis Forum that's facilitated by Rose and Associates. There's the Geopressure Management Network, and just as an example here, there's the Turbidite Research Group in Leeds. So all of these groups enable us to come together and be able to share comfortably information. For example, the Geopressure Management Network, you can share geopressure prediction techniques, experiences from different areas, and then that's used by the industry as a whole to make our prediction of overpressure, while drilling, for example, much better. So these are a few ideas, and I believe that these are all critical things that contribute to success. They're critical success factors. And there's many more things. This is kept fairly high level, but this is what I want to introduce just to begin the discussion on the subject of knowledge sharing. Okay.
Thank you, Gary, to have shared this experience on a real operational subject. It's true that various initiatives from regulators try to promote the knowledge of sharing knowledge, sharing data, sharing well data, seismic data. But what do you think the impact of such initiative from the regulators? Do you have example where there is a really a positive impact coming from the regulators?
Yeah, I think I'll focus maybe on New Zealand, where the data availability is promoted. They're listening to the operators, and it does attract investment. People, there's more comfort to going in, and in some cases you can go in, with studies and so forth, looking at data that's publicly available. So I think in general that's a statement there. I mean, about a specific example I can't really give you right now. But again, I mean, in my experience in Australia, for example, was that data after 3 years go into a public archive. And if I also highlight in the UK, OGA, you can see their, I guess, their stand here, where they have a poster saying free data. So, you can basically go in and take data and analyze it, and for the government, obviously it's attracting investment. For the investor, it's a cheap way to screen through and look at opportunities. So I think these are clear examples, because normally if you go into a new area, you would have to spend millions, tens of millions of dollars on new data, maybe acquire studies or do your own studies. But when there's an established basin, you can actually get data. In the UK, you can get it for free, it says. That's the benefit here for both the countries in question and the investors. It's lowering the threshold to making a decision to come in and invest.
Yeah.
Okay.
Dirk, you have a comment?
Yeah, I think I will agree with it, but I also have a slightly contrarian view. We still, as an industry, feel that the data is proprietary, say, either to the collaboration or the joint venture. I don't think that is sustainable in the end. There will be lots and lots more data, and the adagium, say, in our industry, that those who has the best data or will win, will probably be replaced by those who can interpret and analyze the data best will win. And hence, whether you own the data or not becomes almost irrelevant. And I think one of the biggest transformations we probably will go through in the upstream or in the geoscience subsurface, and hence in particular exploration, is that in essence data will be freely available. I don't think it's free meaning you don't have to pay anything, but it is open for everyone who is willing to pay. Data will be everywhere, instantly, It can be used by anyone who has something to say on this. And that creates a different dynamic in what will then make us competitors or what competitive drivers would be. And I would even go a step further. I really think that companies that are currently really investing in data analytic procedures as we are doing should push that even harder. I just came back from Brazil where a similar law is in place that after 5 years all the data becomes publicly available under certain conditions. I think within 10 years the question whether data is available for anyone will be an afterthought and that the competition will really be focusing on how do you use the data or what data will you use in order to drive a decision and to move in, because not every data will be usable for your options, and the capability to actually translate data into information by means of fast analytical techniques, that is where the playground will be. And that's a big change from what it is today.
Okay, yeah, Tim, you have.
Yeah, could I just pick up on this issue of data availability? But I want to focus on a different aspect, and I really want to focus on the aspect within the company, and at least share examples from ourselves. Sometimes we are our own worst enemy, if you like, when it comes to data availability. We have a tendency to classify and to protect a lot of the data, maybe to a much greater degree than we really need to. And this is one of the findings which we've had just in the recent past. Sort of that maybe the large majority of our exploration organisation have limited access to all the data that's sort of there at least. So it's maybe sort of a 80-20 relationship rather than 80-80 relationship. 80% of people have 80% of the data. And this has generated a big discussion internally, a huge discussion, not least with our IT security people. Yeah. We have reasons for classifying this with data and documents in a different way. But what we've seen is that trend, it can go too far, if you like. And it can go as far, or to the extent that data which is needed, or at least would be particularly useful for a certain type of analysis, is not really available internally because you don't work in that business cluster or you don't work with that region. Mm-hmm. So, just recently I've challenged on this, and I'm basically saying it, and the same as Dirk here, sort of my view on this is that sort of we have to open up. We have to trust others, both internally and externally, more to let them use this data, not to misuse it. And I think just again, I say that relatively simple step. I think making data available, sort of both internally and externally. Sort of it has a huge unrealized potential. I think Ashok Balani, who's head of technology in the Schlumberger, mentioned it yesterday as well. And maybe it was Jean-Georges from CGG. We have this tendency to share data with the service companies only in certain periods of time, and sort of, and then they're kind of out once they've done the seismic acquisition or the processing. Sort of. Maybe there's more of a continuum there that we need to be looking for. So I'm completely sort of aligned with yourself. I think sort of open up, make the data. It is the future, and I think it's really up to us how quickly that future actually comes.
Yeah, just one other example. One other example actually I want to highlight here is. Can you hear me? Okay? Yeah. Is again from the UK, where they actually invested quite a lot of money in a speculative seismic program west of Shetlands, and then made those data available to the industry. So it's a kind of a state-funded, spec seismic survey. And again, I think that's a very positive step because it attracts investment. It lowers the threshold again. And then I would also reach out to government regulators as well, who are not currently facilitating, say, the acquisition of speculative 3D surveys. I mean, there's a lot of seismic acquisition companies who are doing brave things like going out and acquiring data in distant places at, at quite some risk to themselves, hoping to get, say, pre-funding from companies. But if governments actively support or even perhaps co-fund it, and countries where in fact there is such tight confidentiality on individual licenses that you're not actually allowed by law to acquire spec seismic, I would ask them to reconsider that, because it can only be to their benefit to allow the investment coming from seismic companies to come in and cover vast areas of their acreage with seismic, and that attracts investment. So try to remove these barriers to data sharing at these fundamental levels. There are shining examples of where there is this provision for active speculative seismic acquisition, and it can only be a good thing in my view.
Yeah, Remy?
Yeah. Just a small point about, I fully agree about sharing data is critical even in a competitive world. We had that experience a few years ago in Angola, where everybody was looking at the conjugate margin of the Santos Basin in the Kwanza. And after a few dry wells, people decided, the main operators decided to really share the knowledge and share the data. So it was a very positive initiative, I think, to realize that, okay, we didn't understood something in this basin, and maybe sharing data and knowledge, we will highlight some key points that we misunderstood at the beginning. And
Should I go with that?
it is the first initiative that I had in my career on that type. But I really think it is a way forward to share data and to share knowledge, to really to master the basin at a world scale.
Okay, just a question, could be a remark from also one of the participants. Should the global seismic database be shared with the public in a way somewhat similar to how Google's share satellite images? Would this create a lot of benefits to a lot of industry like Google Earth has done? It's a question from Jan de Bruin. So what do you think about this possible initiative? You have comments? Or?
Well, first of all, comment. I think it was wonderful to see the global access, of course, to these surface satellite images. But I imagine that certain countries probably were a bit upset because of their own, say, confidentiality or sovereignty aspects. I think it would be fantastic if the data could be shared, like in a Google Earth kind of format. Sure, it would allow people to look widely in different areas, but I do see that there needs to be a number of very significant barriers removed, which would be the classified data aspects, legal aspects in countries, sovereignty issues. What about sanctions? Some countries you're not allowed to show anything simply because any kind of external view of reserves or what you might have in your backyard in your country is classified. So these aspects are very significant ones. But to answer the first question, yes, wouldn't it be wonderful, to go below the surface and actually look at all the images that are available? That would be a wonderful situation.
Yeah, Dirk?
Yeah, I don't want to sort of be too provocative, but I think it's a bit of a naive question. Of course, data will not be for free for everyone, because that would imply that we don't have any control anymore on not we as a company, but say as parliaments in elected parliaments in countries or political constructs that we voted for may be deprived of their ability to actually set policies that certain people in a country would like to to adopt or to exercise in controlling the natural resources, and why not? So availability of data must be done under a new set of regulations, and I think that's what at least what I meant by having data available. It is not a free-for-all. We will have to come up with a framework that avoids, as Tim was saying, misuses of data, and where misuses is defined, say, by the people who are legally and justifiably the owners, if you wish, of their natural resources. And that could vary from country to country. At the moment, that regulation is stifling any sharing of data, and it is marked with secrecy and confidentiality. That's something that I think we should strive as an industry to replace by more open access, but in a controlled way that observes legal interests that communities and also companies may have without jeopardizing those. I think it could be done, but that won't be easy. I don't think it is something that load everything into Google and then have everyone looking at it. That won't work. There's too much at stake.
Tim?
Just quickly follow up. Sometimes I think there's a little bit of confusion out there about what's being shared and what should be shared and what can be shared. And there's a big difference between sharing public available information, which is basically a lot of what happens across the internet, and sharing very costly data. And sometimes these things get a little bit mixed up, if you like. So I'm with Dirk. It's whilst I'm all for as much access to this, I think we have to recognise the commercial aspects of this. That it's not just about opening up everything here. I mean, there's this big business. Whatever kind of data it might be. And the sharing of information rather than data is something quite different.
Yeah, just a small comment. It would be really a dream to have access to everything. It's a dream. But my God, if it happens tomorrow, what can I do with that? With the stuff that I have? It will be another way of working also. And for sure, the artificial intelligence will be a critical issue to select the data, the key data. So if it happens, it's another way of working for the future.
Okay. Thank you.
I think, Gary, you have
Oh,
another
sorry, Gary.
I wanted to bring up another is there another question coming, or?
Go ahead.
Go ahead.
When I talked, first of all, on my third slide about, data sharing within joint ventures, and I highlighted this very pleasing example of where, OMV, Petrom, and ExxonMobil work together. I mean, but in the past, I know I've worked in ventures with multiple partners where it's been extremely adversarial, and there's been a very much a limited willingness to share information, and those frustrated me, those situations, and I think it's really the duty of an operator in those situations to be the facilitator for sharing as much information as possible, and trying to get the common goal defined for the venture. There should not be a situation, where, an operator could be accused, say, of actually withholding information or not being free enough. I think it's a duty as an operator to provide all of the partners, with the information that they need to come to a joint conclusion. I think some frictions can come in joint ventures from that perception, perhaps, of the non-operating partners that they're not getting enough information. And one thing that can help, of course, is simply, talk to each other, share your thoughts, but the knowledge and information has to be shared, openly and proactively, I think, in these situations. Otherwise, I feel that you do get into a trap of being dysfunctional in decision-making in joint ventures, and this, of course, is detrimental because it can delay decisions. it can prevent you from exercising certain options. So I think I really want to emphasize that for joint ventures, it's really a critical factor to be very willing to share and be open about data. I mean, in your joint venture, you have confidentiality provisions anyhow, so you have to trust one another. But it's just, I showed one, I showed one really good example, but I have experienced other ones in the past where they've been very difficult and could have been better overcome through sharing of information.
Could I just follow up on this one? I'm going to challenge a little bit. Not that I don't agree that we should try to share more across the joint ventures, but again, I think maybe our legacy gets in the way. Sort of we have this procedure, and for those of you who are not really sure, sort of most oil and gas ventures are run as joint ventures. It's not just one company owning 100% of the equity. We share. There's 2 or 3, 4 companies, something like this. But traditionally, we establish common databases, whether it's well databases or seismic, and of course, all of those cost money to own the rights to that. But maybe there's something there again about the model which we need to sort of think about, and I just put it out there as that maybe we need to change our approach, our mindset again, to that, again, commercial aspects. But if we really want to achieve what we're trying to achieve and to sort of share free flow of information, knowledge, data, that's the solution. That's the desired outcome, if you like. Then we actually need to look at the processes which we have in place, the traditions, the commercial models. I think so something there. I think there's something there for us to work on as well.
Yeah, it takes hard work.
I couldn't agree more. I think that if there were regulators who would stipulate that after 2 to 3, 5 years, effectively all the data becomes available under perhaps much loose conditions than currently is the case, it would drive a lot of competition. And it would drive competition in how to actually get newer data in, for which that proprietary aspect is then still in force. So it will renew, I say, your remark about that perhaps it took a bit long to revisit the North Sea. Well, if that happens, say, in an open, slightly more open data area environment, then for sure those decisions to rejuvenate, say, our thinking on mature basins will definitely become compatible or commensurable with that timeline. And I also think that that could extend to a lot more data than, say, just geophysical data. And as that becomes the case, then I guess you will create a much more competition, forcing on aspects. Well, how do you interpret the data, and where is the differentiability then, or the competitiveness really shifting towards analytics and interpretation, away from just owning the data, as it's essentially currently the case.
Okay, thank you very much. We come at the end of the session. So thank you for your participation. Thank you for the debate. I think we cover some key topics of our main activities, with to share the knowledge, the information. We saw a way to improve altogether, including new technologies, as you shared, Dirk, with the project, R&D project. We also touched some of the key challenges we have with the human resources aspect in terms of skill, competencies, motivation, and probably organization. With very good experience from your company. So I would like to thank for the discussion. Thank you. Just to introduce tomorrow executive session, there is also a very good session in this room tomorrow morning about opening a new chapter in the North Sea. What does that mean? Okay, thank you very much.